What did you think first when we mentioned about light? A spark? A prism? Or broader, a firework? A star in the sky? Or something more personal? Your favorite characters from an anime?
世の中を変えてやる
Or the moment you open your curtain in the morning?
Natural light! Get it off me! Get it off me!
But be trustful to yourself. Did you ever wonder what exactly is light?
Different from any object, you cannot feel light. You cannot touch it, nor shake it, neither keep it inside a box. But we still can experience light. Light is nowhere yet still everywhere. We can observe daily objects thanks to light.
As we all know, in order to see an object, it either needs to emit light directly, like a sun or a light bulb or firefly, or else have light bounce off it and into our eyes. However, it took us more time to recognize this fact.
Greek ancient philosophies such as Plato and Pythagoras suggest that vision is accomplished by the light originate from fire inside our eyes, which travel, reflect, and bring back information from objects. It cannot, though, explain how we cannot see objects in the dark room or during night when there is no sunbeam. Arabian philosophies 1000 years later fixed the theories and admit that our eyes just simply collect direct and redirect light from source.
Raw sauce!
But how exactly light can do that? It could be easy for us to imagine light is made of tiny atom-like particles then can recoil from the surface, just like we throw a ball into the wall. However, now imagine two beams of light cross-patch each other. If they're made of solid balls, these particles after collision must bounce off in random directions, which unfortunately doesn't happen. Scientists during 19th century created a series of experiments suggested that light, instead, can have pattern of wave, which also can reflect, refract, as well as substantial diffraction and interference characteristic.
So in conclusion, light is wave, right?
Nah, not really. This part is what should I call black magic. Depends on the experiments. Sometimes we observe that light has some wave characteristics, some other times we see light has particle features. In quantum physics, scientists admit that light is somehow both wave and particle at the same time. It is similar to the Schrödinger cat, which can be half-lived, half-dead inside unseen box. The action of observing itself already decides the cat will be alive or dead, or make light becomes waves or particles.
Okay, stop it right there. How knowing all of these things relate to our class anyway?
Okay, enough. I know what I'm talking about, okay? Sun is an unlimited source of clean energy for Earth and living things. We receive around 173 terawatt every moment, which is 10,000 times more power than the planet's population use. As this energy is provided mostly in form of light. Without knowledge about it, how can we fully optimize the potential of this power?
So the first question, how light can give us energy? How sun rays can warm up brick walls, can melt ice and snow on the street. How it can transform through solar panels into different type of power, electricity. From previous section, we mentioned that light sometimes acts as a flow of tiny particles, right? These particles, called photons, shoot straight out from the sun with specific velocity and strike the electrons inside surface of brick wall or snow, which finally get excited and begin to move. This kind of motion in atomic level is recognized as heat energy.
The same situation can be explained for the energies transferring through solar cells. But the material is designed uniquely to gain electricity instead of heat. To simplify, this material is a conductor which is made of N-type and P-type silicon, which can create an inner electric field when they are stacked next to each other. This field keeps electrons after the collision with photons from the sunlight constantly move in one direction, which, in other words, hold that electricity.
The second question is, if light can give us energy, how much energy it can give? Can it be answered quick second characteristic of light as characteristic of its waveform? Actually, before answering this question, we need to know that there are many types of light, which are distinguished by the size of their wavelength, from the size as small as an atom to as big as the Earth. When we mention light, it normally the spectrum of visible light, which has wavelength from 408 nanometers to 700 nanometers. And if you did the homework, you must know that this is a spectrum of rainbow, with each of wavelength is one specific color. According to Max Planck and his research in 1900, this wavelength, besides to separate kind of light, is a main factor to decide its level of energy that the light can carry, with the formula E equal hc over lambda. S E is energy, h is Planck constant, and c is light velocity, and lambda is wavelength. This shows the violet light in the visible spectrum has the highest energy, while red one is the lowest. Interestingly enough, the relationship between wavelength and energy is figured out from 1,000 years ago, when Chinese people came up with the idea using higher pressure and temperature to burst out fireworks with higher energy colors, violet.
The third question is, how well mankind has managed to use this kind of energy? In 2016, solar can produce 76,600 megawatts, supplying only 0.15% work-consuming energy, which is about 10 terawatt, which is quite trivial compared with the amount of energy we need in the future. However, growing rate of the solar annually is surprisingly large, about 35 to 40%, which means by 2050, it can provide about 50 times wood consumption and substitute all the fossil fuel resources. Even though, to continue using this energy, there are several difficulties that we need to overcome in recent future, such as geographical location, producing processes, and installing costs.
Energy of light? I wonder if it has dark energy or not.
Actually, there's dark energy too, but it is maybe go over our topic today. Light itself still has many things that we cannot understand and need time to explore more. It is quite difficult to understand the characteristic of light, but it's going to be beneficial in many aspects if we can fulfill comprehend it.